flanger and the chorus are included because they're Jellybean effects every program should have. The flanger is a single channel effect. If you attach a shared version to multiple tracks, each track is processed separately. The trick with the flanger is it's a time-varying effect, where the time is relative to the last keyframe or the start of the effect. You normally have a piece of music where the flanger is supposed to peak on a certain beat. That timing is created with a keyframe. To hear the flanger more directly, it's helpful to use a sine wave. The flanger works by overlaying a copy of the input waveform on the original. The overlaid waveform has a constant delay and an oscillating delay added to it. The phase offset is how much the constant delay is. The depth is how much the oscillating delay varies. The phase offset plus the depth is the total delay the flanger is going to apply. This causes the phase of the original waveform and the delayed waveform to vary. For a sine wave, the total delay is meaningless for values any larger than the sine wave period. So to have some breathing room, we want to use a low frequency for demonstrating a sine wave. For a 200 Hz sine wave, the longest meaningful delay is 1/200 or 5 milliseconds. So for the demo, we'll use 2.5 milliseconds for the phase offset and 2.5 milliseconds for the depth. Giving a total offset of 5 milliseconds. The starting phase is where the oscillating delay starts in its oscillation. This is relative to where the start of the effect is, or the last keyframe. The rate is how fast the oscillating delay oscillates. The wetness is how much original waveform is applied. Since we're adding a full original to a full overlay, the track should be faded to -6 dB. The easiest way to see the result of the flanger is to render the output to another track. With these settings, we get a total cancellation at the beginning and a doubling of the sine wave at the middle of its oscillation. If we enable keyframes, we can make the flanger start at a different time. Here we start with a depth of 0, so it doesn't do anything. Then, at 2 seconds, we increase the depth to 2.5 milliseconds. We also have the starting phase at 0, so this will be the point where the waves cancel out. And as you can see, it rendered total cancellation when the depth was 0, and then when the depth was 2.5, it started phasing into a doubling of the sine wave. Now let's render the same effect, but change the starting phase to 50%. In this case, it created the maximum constructive interference where the keyframe is, because it started at 50% through the oscillation time. It's better to use keyframes to start the flanger than to shift the start of the effect. The flanger relies on a history buffer to properly flange. Let's not use keyframes and just shift the start of the flanger to see the effect on the waveform. Press Shift and middle click to move the start of the flanger in. Then instead of a keyframe, we'll set it to start with maximum constructive interference, 50% starting phase, 2.5 depth, 2.5 offset. So this time, the original sine wave is passed through unchanged at minus 6 dB because we have no flanger. Then the flanger starts at maximum constructive interference. But as you can see, it didn't start exactly on the start of the flanging effect. We actually get a delay where the flanger is filling its history buffer. For shits and giggles, let's visualize the flanger on the spectrogram. With these settings, you can actually see the original sine wave, and you can see the delayed sine wave oscillating back and forth. The delayed sine wave oscillates between one fixed frequency offset and another fixed frequency offset to give a constantly varying phase. When the two sine waves vary very closely in phase, you get the flanging effect, and it's much less visible on the spectrogram. Another interesting effect others do is send white noise through the flanger. When the white noise is phase shifted over an identical copy of itself, you get patterns of cancellation that look like a waving comb filter on the spectrogram. The next application of a flanger is a chorus, for which we have another dedicated effect.
To ponder this thought experiment. If the zombie apocalypse were to happen today...
So here we have a monaural podcast, which is being converted into a stereo chorus, using the chorus effect.
That question than Max Brooks. He wrote World War Z and The Zombie Survival Guide.
The chorus is exactly the same as the flanger, except the starting phase is replaced by a number of voices per channel, and this effect modulates pitch instead of phase. The starting phase is fixed and based on how many voices there are. The chorus is a multi-channel effect, and each track is a channel. If you have 4 voices per channel and 2 channels, it'll create 8 voices. We have a constant phase offset plus an oscillating phase depth for each voice. The voices are evenly spaced in the range of possible phases. But when the voice count exceeds 4, the voices tend to generate artifacts. Let's play back while increasing the voice count. Also notice it's severely overloading.
Or when it does, is easily fixable. We have a society that is engineered for comfort and not for resilience. And that comfort is based on a global supply chain. And in a zombie apocalypse, in a not even a real apocalypse, in an earthquake, in a flood, in a fire, in a plague, in any real event that could happen, that global supply chain could be cut.
The higher voice counts are less useful for music and more useful for sound effects.
Think about all the things that keep you alive and think, what can I fix myself?
Now let's increase the depth. Increasing the depth creates more separation between the voices, but also causes the synchronization to be worse, and also will start creating aliases, as it has to vary the pitch a lot more.
What would that be?
Yes, I've got a crazy, wild invention. It's called a water purification filter.
Another effect the chorus or the flanger can create is a vibrato. Turn the wetness to infinity so we only hear the modulated sound. Set the rate to 4 Hz. Set the depth to 4 milliseconds.
I read World War Z and actually the Zombie Survival Guide, and I constantly talk about things like, I don't want an electric car to be my only vehicle because what if the zombies come? And it's sort of a shorthand for all kinds of disasters that you could argue people all over the world are starting to experience as climate change becomes more and more of a reality. Do you think that there is value, even if we talk about it in this sort of metaphorical way, in thinking about how we might survive a zombie apocalypse because it means all kinds of apocalypse?
Yes.
It's easier to see a vibrato on a spectrogram. So let's create a project with just a synthesizer and the chorus with the vibrato settings. Here, the difference between the flanger and the chorus is obvious. The chorus gradually changes the pitch over time, where the flanger toggled between two pitches in order to change the phase. Flanger configured for vibrato. The final essential audio effect is the tremolo. This oscillates the loudness. Let's create a standard tremolo demonstration using a sine wave and visualize the result on the spectrogram. The spectrogram makes it easy to see the volume changing. The phase offset is where it starts in the loudness oscillation. The phase offset, like the flanger, is always relative to the start of the effect or the last keyframe. The depth is how far down the tremolo lowers the volume. At 40, it lowers the lowest point to being muted. At 0, it doesn't lower the volume at all. At 6, it lowers the volume by half. The tremolo only lowers volume. It doesn't increase volume. The rate is how fast the oscillation repeats. There are a number of different waveforms to use for the tremolo. The spectrogram can show you the difference between the waveforms. Set a large depth and a low rate to see the variations. Starting with a sine wave. Sawtooth. Reverse sawtooth. Square. And finally, back to the triangle. Notice when the tremolo starts, it currently starts at the loudest volume. Let's set the phase offset to 50% and see where it starts now. Now it starts at the quietest volume because we adjusted the phase offset. Let's adjust the depth and observe the change. Now it's adjusting the volume much less. Finally, let's adjust the rate. One trick you can do with the tremolo is make a track pan between two speakers. So let's load a monaural soundtrack so the sound is the same on both speakers. And now let's attach tremolo to both tracks. We're going to uncheck the shared plugin option. So it's going to attach a unique plugin to each track. We're going to make one track 50% phase offset and the other track 0% phase offset. Set the depth to maximum and set the rate slow enough that you can hear the difference.
It is Halloween today, which means there is no
And now
better
you can
time
hear the
to
sound
harvest
panning
live
between
content.
both tracks.
If the zombie apocalypse were to happen today, what tech would you want with you to survive? Now, there is perhaps no person